the internship we did in the summer.
Yeah. Understand.
But
But did he came to Malta, or you did on online, on remote?
He came to Malta for the practical part.
Oh, nice.
But rest, everything is done online.
Yes, still the same problems everywhere. But anyway, I hope this summer, I don't know when, or later on this year, to be able to come to Malta, you know, also for the practical exercise, you know, on the gas. But I believe that you already have seen the analyzers they have you have in your facility. I believe Massimo shown you the different analyzers and what's available on the side of the compressor, of the gas compressor. Or haven't you gone there yet?
I saw the fancy DOX color analyzer because Massimo is showing it off on the right side.
Yeah. Correct.
But officially, we did not have any lessons or about it. We just saw it. Okay. I believe that Arcadius was in the group in July. I think they saw it as well.
No, we didn't have it before. We just saw it now when the guys from the second year they had the technical.
So we saw all together. We glimpsed it all in the same way.
Understand. But anyway,
complete. That does everything. Yes, it does all the testing for our ISO standard. Yes.
Yes, correct. That is a whole unit, and if I'm not wrong, the unit doesn't have is a unit that analyzes oxygen, carbon monoxide, carbon dioxide, humidity with the highest accuracy, and VOC oil vapor. So the 5 parameters that have to be.
And helium as well.
Yes, of course.
And helium. So it does helium as well.
No, helium is not. Helium is not in that configuration. Yeah.
It was helium as well. All right.
Yeah, also because, as I told you, helium is a different. When you have helium in the gas, the sensors, mainly the electrochemical sensors, behave in a different way because the diffusion of the gas into the membrane of the sensor. You know, this is a sensor. And the way the carrier gas, that is the inert gas, the nitrogen or helium, pass through the membrane is very different if you have a helium, and it changes the reading of the sensor. So for avoiding this, you have to do the calibration that we are going to talk today about this topic with a gas containing helium. And go.
So the calibration of the sensors, we do it with the helium instead of nitrogen, so to say.
Depends on the gas you have to measure. The calibration is a process that you do for making, let me say, the sensor comfort with the gas that you are going to analyze. You know, the closer you have the gas, the calibration gas, to the target gas you have to analyze, the better it is for the accuracy. That is the main tip of all the gas analysis.
When we have trimix, we normally calibrate the oxygen sensor in air.
Yes.
And then we measure the oxygen level in the trimix.
Yes, but
that is not it's not giving us an accurate reading because the helium makes.
You're right, Arthur, but this happens because the accuracy that you accept for the oxygen sensors is 1%. Okay.
Right.
If you want to have a very smaller, you know, shorter accuracy, I mean, lower error, below 1%, you need to use the gas, because if you have exactly gas, let me say 15 oxygen, 35 helium, and you have 15 oxygen and 85 nitrogen, you will see that using the same calibration, the oxygen analyzer will give you different reading. Understand? So, but when we do our trimix analysis, we generally accept, you know, 1% plus or minus, and that's okay. That is the range. But if you want to have a very, very smaller error, a short reading, then you have to use the same. I'm saying that for the experience coming from the saturation diving operations. When the gas analyzers are used in the calibration in the hyperbaric environment for saturation diving, the norm, the regulation state that they have to calibrate the gas at least every shift, meaning every 12 hours, with the sample gas that must be closer as possible to the gas they are breathing. For instance, if they are working at 200 meters, the equivalent depth of 200 meters, 20 bar, they generally have a 1.5% of oxygen, and the rest helium. They have sample gas, 2% oxygen, 98% helium. And with this sample, they do the calibration of the oxygen sensor. And in this way, they have the very best accuracy. Understand? So,
Okay.
but of course, we are talking about professional, we are talking about long operation, 1 month, 2 months in saturation. You are talking about also life risk. You are not talking about recreational. You are not talking about you know, dive of 2 hours, 3 hours, you know, or rebreather 4 hours, 5 hours, you know, that's totally different. But just for giving you the concept, you know, the calibration, that is the most important activity. So,
And the error is negligible for our uses then.
Yeah. No, absolutely. Don't worry. I mean, in the sport activity or what you are going to do, the sensors accuracy is more than enough, I tell you. And also, we use a special sensor that are manufactured just with our specification, and that have a less than 1% error in nitrogen. So that's a very good quality, because generally the sensors have 3% of accuracy, not 1%. This, if you read well all the data sheets of the sensors, you will discover that the generally declared accuracy of the sensors is 3%. You know, because there is also the temperature. And but we go ahead. Okay, hello Damien, nice to see you. So guys, do you believe that can we start, because it's already 10 minutes over the date?
Yes, I believe you can. Maybe it's good that we record it for the ones who are not unable to be present.
Yeah. We are recording. We are recording now, so don't worry. Yeah, we are recording. Okay. So let me share the. Okay. Can you see now the screen? Full screen?
Yes.
Okay, good. So, just a quick remind what we did last week. We talked about nitrox. What is nitrox? You remember the earth that provided God provided earth with nitrox known as air, but is not the best for diving. You remember the joke of the Noah diving founder. Then we talked about the Dalton law. You remember that is extremely important because states that a gas behaves as it is alone, just considering his partial pressure and in a mix, provided, of course, that there is no chemical interaction among the gases that are in the mix. And then also Dalton law helps us in understanding that the total pressure of a mix containing different gas is the sum of the partial pressures of the singular gas. In case of trimix, we were talking about trimix, you have the partial pressure of oxygen, nitrogen, and helium. Forgetting the other components of air that generally are used for blending the trimix, meaning the CO2, the argon, and other traces of gas. By the way, just a joke, I want to tell you that when I have some of our friends that attempt to do a record for deep diving record, what I always suggest, because of course we support most of them for the analysis, for the gas analysis, and with our advice on how to carry the operation, what we do generally is to suggest to do trimix fully synthetic, meaning using booster and using pure nitrogen, pure oxygen, pure helium. We don't suggest at all, we don't advise them to use air for blending the gas. So all the cylinders are prepared with pure gas. In this way, you have the low risk of putting carbon monoxide or putting oil. Of course, you have to use a booster pump, for compressing the cylinder. But in this way, they have a very, very, very safe mix. But that depends on the budget, to buy directly from the gas supplier the gas already mixed, and the synthetic mix, like the saturation diving company does. They already they don't mix when they go on operation for saturation diving. They buy the gas already mixed, and then they use the gas already mixed for the best situation. Then of course they have also spare gas, pure gas, that in case they mix for the necessity. Okay. Well, going ahead, we spoke about international norms and the regulations. We saw how many norms and regulations are available, and remember my tips, my advice. Wherever you are in the world, please be aware of what's going on on the regulation or local regulation, and be aware of that, because the worst thing is just ignoring, just not knowing. Because if you know there is a regulation and then you maybe are not so compliant, but at least you can see how you can justify in case of an advice, or in case of any inspection from the local authority. Not knowing at all is the worst scenario that you may have in your diving organization. Okay, so after then we went to the NITROX analysis. So we spoke about the analyzers, we spoke about the sensors, we spoke about the different kind of analyzers that are available, and we spoke also, of course, about the error and accuracy. So this is why I was telling you before about the the accuracy of the 1%, but we're going to speak longer for these topics. Okay, so is any other question you have from the last lecture, guys? No? Okay.
None from my side, at least.
Yeah, okay. From mine, I mean, I knew that this material as well.
Okay, good. That's good. So I told you, I hope not to bore to bother you so much, you know. And then this is why I'm trying to tell you stories about that are not known, that you of course may read in the literature, in you may find on the internet. But it's nice, you know, the experience, the real life experience that we have doing this job, you know, in the gas. Okay. So now we can go ahead, and this is the topics that we are going to talk today. We are going to talk about the calibration of the analyzers, of the sensors, the importance of the pressure, of the temperature, of the flow. That is extremely important, and also the humidity, the local humidity that you may have, because the hotter, the more humid you have, the worst scenario is for you for making the analysis. Then we will talk about the procedures, which are the procedures that we have to follow for performing the best possible measurement. We are going to talk about the accessories. I have here some accessories that we use for the analysis, that are the flow restrictors, that are the flow regulators, or the single regulator as well, the scuba regulator. Then we are going to talk about the measurement tips. So what you have to do, what you have to avoid, and what you have to let your student and also customer, in case you are running your diving center, you know, what they have to do and what they don't have to do, you know, for extending as much as possible the life of the sensors, of the gas sensors. After that, we will have a practical exercise. I have cylinders here with gas, and then I would like to show you physically, practically, how to do the analysis, and hoping, of course, to meet in person. I don't know when, but that for sure will happen, and then we can do in Malta, and maybe before diving, so for having a dive together. So then, of course, a summary and questions, but please, I always tell you, please don't, you know, if you have something that is not clear or you don't understand my English, please stop me, and then I will try to answer you or to repeat in a better way. Okay, so don't be afraid of stopping me and jumping into the conversation. Okay, so well, now let me go ahead with the presentation. Okay, well, so let's start with this with the topic about the calibration. Why is so important? Why I'm very, very concerned about the calibration? Because calibration is the most important task that you may have when you do gas analysis, when you give nitrox, when you give trimix, when you give any kind of gas to your customers. Because from the calibration, you have the chain of the accuracy, of the error, and of course the reliability of your organization. If you can see on the right side of the picture, that is our factory in Italy, and then you have just a small view of the cylinder, the calibration cylinders that we have here. So all these cylinders are cylinders containing certified gas. They come from the supplier, the gas supplier. Typically, it's Air Liquide or Sapio or SIAD, or the typical gas supplier, and they provide us this mix that are certified, meaning that they have a certificate. They use the gas chromatographer, so the highest possible accuracy analyzer, and they state the concentration with the certificate. And then we use this gas for recreating the measurement chain that is referable, as we say in metrology, with the international sample. So if you calibrate an analyzer with this kind of cylinder, with this kind of gas, certified gas, you may prove, and then you may give confidence, reading and error and accuracy to the user, to the analyzers, and of course to the final customer. Okay. Why is so important the calibration? Simply because the sensors are differential, not absolute. I mean, when you have this sensor, this is the typical oxygen sensor. The sensor gives you just a millivolt output, a tension, okay, a volt tension. And for translating this tension to a value that is readable, meaning the concentration, you have to know the point of start. So the millivolt that you are reading in this point, in this moment, which is the real concentration of the gas. And now on, when I stated that this is the known concentration, I can do the analysis, because in this way I already stated, I said, okay, sensor, you give me 15 millivolt in air, 21% of oxygen. So now on, any kind of change of millivolt, I will translate in a change in the concentration. Okay, but don't forget what I told you last time. The sensors are sensitive to the partial pressure of oxygen. So this is, we go back to the Dalton law. Is not sensitive to the concentration. So what does it mean? It means that if I give pressure on the sensor with the same gas, I have a different reading. Just for giving you an example, if I have an oxygen analyzer reading 21%, I calibrate in air, okay? Then I put the same analyzer inside an hyperbaric chamber, okay? And always with air, I don't put any kind of oxygen, helium, nothing, just air. And then I go down 10 meters, okay, meaning I double the pressure, so I go 2 bar of absolute pressure. The analyzer, if it's well calibrated, if it works well, will show you 42%, so double of 21. But the concentration is always air, you understand? But the partial pressure is double, and means that from 0 to 21 you go to 42. Understand? So this is extremely important. And this is an effect that you have also with the temperature. You have with the pressure, of course, we already told, and with the flow. Because the gas flow that comes from the sensor to, from the cylinder to the sensor may affect the pressure on the sensor, on the membrane of the sensor, and then may affect the reading. Understand?
What you said, chamber.
Go.
What you said, the chamber only happens if you calibrated it at 1 atmosphere.
Yeah.
Right?
Correct.
You calibrate at 1 atmosphere, you go down to 2 atmospheres, and it will read 42%.
Correct.
Correct. Now, if you calibrate it at 2 atmospheres,
yeah,
then it will come back to 21%, right?
Correct. Yes, correct. This is exactly what I was meaning. So if you have an hyperbaric chamber, you are into the hyperbaric chamber. You know that there is air. This is the sample gas. And you are sure that you are air 2 bar, you can do the calibration 21. And then at the same pressure, if you increase oxygen, the analyzer will read the real concentration, because now you are constant pressure. Understand? So this is the way also the sensors work in the rebreathers, you know, because the sensors are calibrated in ambient pressure, you know, at 1 bar and one, I mean, that would be 1013, but then depends on the barometric pressure. But anyway, let's do easy. And we calibrate the sensor of the rebreather. Generally, we use a pure oxygen, you know, so we have 1 bar of oxygen, and then from that point, the sensor is just sensitive to the partial pressure of oxygen, not to the pressure. Understand? And then the analyzer installed on the rebreather will just give you the partial pressure of oxygen, okay, based on the calibration that you did on air on 100% and 1 bar, okay, because the sensor have this behavior. Okay, so then of course there is some cross-reference with the pressure, some cross-reference with the helium, some cross-reference with other gas. Okay, but we try to keep this kind of side effect, this cross-reference, with the total accuracy. We say 1%, 2%, that's all, you know. In this 1% or 2%, you have all this fact. But don't forget that if you need to have highest accuracy with the sensor, that is possible to have, you have to use constant pressure, constant temperature, constant flow. Okay, that is extremely important. Another tip is the closer the better. What does it mean? It means that the closer you do the calibration, the gas calibration, to the analysis point, to the target gas, the best accuracy you may have. And also, not only for the concentration of the gas, but also with the carrier gas, meaning with the inert gas, with the nitrogen or helium. So understand, with this, you may, I mean, if you have, you are going to analyze an hyperbaric chamber in a saturation dye that are using 2% oxygen and 98% of helium, the best, the possible gas for doing the calibration is not air, but is 2% oxygen, 98% helium. That if you do the calibration at this point, of course, you may have the best accuracy on the sensor. Okay, now you may say, okay, Eugenio, but we are not talking about the saturation dive, you know, we are just talking about our diving center. Correct, you know, but it's important that you know. Just for giving you an example, you had to do analysis of an 80% of oxygen or a 50% of oxygen, of 32% of oxygen, which is the best calibration point. Luckily, in diving, we are very lucky because we have air available, and then we have always in a diving center a cylinder filled with air. And we have pure oxygen generally. So that is the main gas that we may use for the calibration, for calibrating the analyzers. In this way, you may do the calibration. For instance, if you had to do the analysis of an 80% of oxygen for maybe for decompression or 60%, is it better to use pure oxygen for calibrating? You know, you put the analyzer at the 99.8, and then in this way you can see the effect. You can see
on the money transfer is their error.
I'm sorry. Sorry, guys, I had a call. So I was saying that the most important thing is to be as closer as possible. I mean, if you had to analyze 80%, it's better to do the calibration at 100% because you have only 20 points of difference. If you calibrate the analyzer at 21% and you go to 80%, you have 60 points, you know, of difference. And this difference, there will be a linearity error that may affect the reading. If you are going to analyze 32 or 40% of oxygen, is it better to use air? Okay, so in this way you may have the best possible situation, because I told you, the closer you do the calibration, the better is with the analysis. Okay, another important, very important point is the temperature. The temperature is extremely important because the temperature affect also the reading. So because the temperature change the way the gas have the reaction inside the electrolyte of the sensor. Okay, so the higher the temperature, the gas temperature, the higher the output of the millivolt of the sensor. The lower the temperature, the lower the millivolt. There are two nice episodes that I want to share with you. One was in a couple, three or 4 years ago. So I was called by a diving center that is our test center, and they mixed a 50% nitrox. That was a typical, you know, the typical decompression mix, you know, for the 20 over meter. And they were crazy because they did not understand, because they did the mix. They just filled the cylinder, the empty cylinder, with pure oxygen, and then they topped up with air. And they did with a manometer, with a very accurate gauge, and they did, you know, the pressure that was perfect. They did the calculation. Then when they went to analyze, the gas was not at 50%, but was at 85, 86%. So, and then they were crazy, you know. But what's happening? Why it was so different, you know? Then the problem is that generally, when you have a gas analyzer that is not working well, generally the sensor that when the sensor is old, reads a lower level, you know, lower concentration, not higher. So if they had 50% into the cylinder, how was possible that they were reading 70-80%? You know, it was totally crazy. And then, you know why? Okay, I tell you the story. All the tests that we did, it was because they used the oxygen, the pure oxygen that they filled into the cylinder, that was hot, that was under the sun. So the gas temperature that went into the cylinder, even if the cylinder was normal, was a standard temperature, it was on the shade, was not under the sun, it was a higher difference. So when they put the pure oxygen that was hot with the air coming from the compressor that was at ambient temperature, the mix didn't happen well. You know, that was a stratification of the temperature, and the gas didn't mix. You know, how we discovered that? Because we left the cylinder there. I had some concern, because that when you blend the trimix, you have to shake, you have to roll the cylinder, because the helium tend to stratificate inside inside the cylinder before having an homogeneous mix. And the day after, when the temperature was down, the mix was perfect. It was at 50% of oxygen. So this is the other tip. Take care of where you store your gas. of course, the pure gas is not good to store. Any gas is good to, any pressure cylinder is good to store under the sun, you know. But in case something like that happens, be aware that also blending oxygen and air for doing the nitrox without being careful of the temperature must be the same. You don't have a good mix, and then you don't have the right analysis. So, and this is extremely important when you do the calibration, of course, and then when you do the analysis. Okay, why is extremely important? Because when you flow the gas from the cylinder, you already have a drop of pressure, because you go from 200 bar of the cylinder, or whatever is the cylinder, but generally you do the analysis when the cylinder is fully filled, you know, the 200, 250 or 300 bars, depends on how you work. And then you have to reduce the pressure, because the sensor is not only the oxygen, but all the sensors work in ambient pressure. Okay, and this drop of pressure generally create also a drop in temperature. Now, you know that when you leave open a valve, totally open a valve of a cylinder, you know, the drop of the pressure freeze the valve, and now you have ice on the valve, you know. So the same happens with the analysis. If you don't take care of the temperature, you are not able to do a good analysis, and of course a good calibration on the other side. So this is why when you are in a higher environment, when you are in a high temperature environment, you need to have the sensor at the same temperature of the gas, both calibrating and analysis. Okay, the gas, the target gas that you are going to analyze. So this is extremely important, and this is the most common source of error of the analyzers, because maybe the analyzer was left under the sun, the sensor is hot, you know, so you make a calibration with a hot sensor, and then you pretend to analyze a dive cylinder that is with a lower temperature. Understand? This is extremely important, because also this may give you 1, 2, 3% of accuracy. Yeah, and also with the helium analyzers, just for opening a bracket on the discussion, you have the same behavior. If you leave the sensor under the sun, and then you perform an analysis of helium, the sensor, I'm talking about the sensor based on the thermal conductivity technology, they have an error. Of course, we have a formula for making the compensation. So even if you use a different temperature, you know, we do that. All the sensors, I forgot to tell you, have also inside the electronic, okay, this is a electronic of a sensor. They have some components here. One of the components is also a thermistor, so is a thermic compensator. So it makes the output of the sensor stable, whatever the temperature is, you know, because it changes the resistance, and then add or reduce the resistance, and then gives you a stable. But it needs time, you know. It's not immediate. So if you have a flow that goes from the cylinder that it is 10 degrees different in temperature of the sensor, this 10 degrees you must wait that the sensor chill down and the thermistor, the components chill down to the same temperature, otherwise you have a wrong analysis. So this is why when we tell about the procedure of calibration, the first calibration that you do when you start must be the longer. You have to flow gas for 1, 2, 3, 4 minutes on the sensor, then you calibrate, and then you forget the sensor. Then the sensor is already calibrated, and then you don't do any other calibration. So you do all the analysis for the next hours, you know. And this is a tip that we are going to talk later. Okay. So do you have any experience with this, guys, with the calibration? Arthur?
Yes, I tend to be doing a lot of calibration and measuring of oxygen.
Yeah.
Not
Go, Arthur.
For cylinders, the mixes and all that. And we also do some medical oxygen concentrators. And so I am constantly checking the output of their oxygen and so on.
Correct. Correct. Because when something is wrong, you don't know why. You have to discover, you know, is the flow, is the temperature, is the sensor, is the gas. I did a wrong mix. Okay, when you use a pure oxygen medical grade, you know, you are 99% sure that there is no issue. But you remember what I told you last time, you know, about the rebreather that was used, the oxygen rebreather that was used with the pure oxygen. They were supposing that was pure oxygen. It was only 80%. And then we had an accident. So that may happen. You know, never trust. You know, just do the analysis by yourself. This is a golden rule of the gas analysis. You know, just don't be rude. You know, just be polite. That's very important. I tell you a story that happened to me last September. Oh, go, Arthur. Sorry.
No, when we measure the oxygen concentrators, which produce between 92 and 96% oxygen, we calibrate it on air, to tell you the truth. And we do find sometimes some problems of accuracy, and we have to adjust for it. But maybe, yes, we overlook the importance of leaving it long enough to adjust it. And we're doing it with air. Ideally, we calibrate with oxygen.
Yes, you're right. Because in theory, if you have constant pressure, constant temperature, constant flow, stable, that you have a laboratory, blah, 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 blah. If you calibrate well the sensor at 21%, there is no reason why you don't have to have the better accuracy, the best accuracy also at 100%, close to 100%. But don't forget, Arthur and guys, that the most of the time you are not in the laboratory, you are not in a constant temperature, you are always in a mess, you know, diving, the boat is leaving, the customer is late, the compressor didn't produce enough NITROX in time, so maybe you're rushed, you know, then you may do some mistakes. This is why you have to know, and then you accept, of course, some kind of error on the analyzer, on the sensor, on the procedure itself, you know. But you know, you just have to know what happened. Then, of course, you have to adapt yourself on the situation. So I was telling you the funny story that happened to me in last September. You know, we attended to the ADEC show in Singapore. We provided some gas analyzers, NITROX, helium and oxygen analyzers to some diving center of the area. So they went back to us, say, hey, we are calibrating the analyzers at 20.3% of oxygen, and then the reading is not good. I said, sorry, why are you sure that you have 20.3%? Do you have a sample gas? So no, we just use ambient air, and ambient air at 90% of humidity, at 35, 36 Celsius of temperature. So we have around 23%, 20.3% of oxygen. I said, yes, it's correct. But are you sure that you flow the sensor for the calibration with the same gas? Are you sure that the temperature was right? And I gave them the tip. The tip is to use air, compressed air coming from a cylinder Then you flow this air, this synthetic air, let me say, air into the analyzer. You don't use the ambient air, you know, full with humidity, and you use the gas as a calibration gas, and you assume that you are 21%, not 20.3, because you use a dry gas coming from the cylinder. You have a flow that you can freeze, that can chill the sensor. Then you have the same flow, and then in this way you make a very good calibration with air. Then when you did the calibration, even if you leave the sensor in high humidity, you don't care. Okay, maybe the concentration of oxygen will drop when you leave in air, of course, because there is a high humidity. But when you go and analyze the cylinder, the gas is perfect. So that's my first tip, you know, use always a cylinder with air for making the calibration. Okay, unless you are like now in my office in Milan, that you have 21%, you have 60%, 50% humidity, you are in a perfect environment, and then you may use this ambient air for doing the calibration. Okay, understand? But that is extremely, extremely, extremely important, not only for the oxygen, but also for the other gas. Generally, the other gas in the analyzer doesn't need to be calibrated, you know, because helium, carbon monoxide, carbon dioxide, humidity, they are already calibrated. They are calibrated in the factory, and then after that you just have to measure based on the calibration of the original calibration that it was done by the manufacturer. So, but for oxygen, no. The oxygen with the electrochemical technology, you need to do the calibration because the analysis, because the value change. There is a big difference if you keep the sensor at 15 degrees and if you keep the sensor at 30 degrees. The millivolt, even if it's in air, is totally different, you know. So then you have to balance, you have to be sure about that. So another episode I want to share with you is with the rebreather sensors. You know, I had a customer calling us and claiming that the sensor was not working, was very, very slow on the rebreather, you know, when they were performing the calibration. And okay, I asked, but where are you now? Okay, we are in the mountain, we are on the lake. It was winter, you know, so it was a nice dive. And okay, but sorry, did you leave where did you store the rebreather? Oh, say, well, we put outside, you know, it was in with the diving gear. So meaning that it was minus 10 degrees. Yes, it was around minus 10. I said, okay, guys, what you pretend? The sensor needs to work at least at 5 degrees, because if you don't keep the sensor at the right temperature, between 5 and 30, 40 degrees maximum, the sensor is very, very slow. And if you go below 30 degrees Celsius, the electrolyte inside the sensor will freeze. So then it won't be able to do the right measurement, because of course the reaction inside is affected. You know, it's not possible that the chemical reaction is not working. So always be careful with the temperature, okay, mainly in summer, because when you are in summer you forget the analyzers under the sun. Then you take the sensor inside is 40 degrees, 50 degrees, then you go on the cylinder, then the gas cylinder going out the cylinder is 15 degrees, and then you have a mess. So, oh my God, the sensor is not working well. I have 3%, 4% error. Or worse, you go and then you call the blender of the diving center. Hey, what the hell you did on my cylinder? I was waiting for a 50%. I was expecting 50%, and then you gave me 40%. How is possible? And then you swear, God, no, I did good. I checked. I was very, very sure that it was 50%. You know, this difference also 10 points is possible with the difference in temperature. So be always aware of this, okay, when you do the analysis, when you do the calibration. Okay, questions, guy? It's clear.
clear.
Okay. Well. Okay, at this point, let's have a look at what's available, you know. I have here some, okay, let me stop the, okay. You see me full screen now? Guys, hello?
Sorry, but we turn. I see your face full screen.
You've seen, okay, good. So, okay, what is necessary for the analysis? Okay, generally, the easiest way is to, you know, to use the rubber cap. So this is a rubber cap that you put on top of the sensing part of the sensor. You put on the cylinder. You first turn on the cylinder very slowly, and then you put the analyzer on top, you know, and then you do the analysis. But in this way, okay, this is the easiest, this is the fastest, this is the what you 90% of the time you will do, you know, and that is for most application is the best way, you know, of doing the analysis. But be aware that there are also other accessories. One of for sure of the best is the flow restrictor. Okay, this flow restrictor you connect to the cylinder, then you have inside the needle valve stainless, then you gently turn on, and then you have here flow that is a constant temperature, constant pressure, and constant flow. That is the best way for making the analysis. Now we are going to do the analysis with a different way, and then you will see the difference. You will see the difference in the analysis. Another way of using is the flow restrictor from the BC hose, from the jacket. So you just have to remove the adapter from the sensor, and then you just screw on, okay, to the analyzer. In this way, you just connect the analyzer to the cylinder. Inside here there is a nut, there is a spring, and it's already calibrated for the flow, the constant flow that it's around 1 liter per minute. And then in this way you provide the best flow and the flow at constant temperature, constant pressure to the sensor. Okay. Another is the medical adapter. You see, this is a typical flow meter for the oxygen cylinders. You have possibility to replace the different heads. You know, you can put the helium, you can put the yolk, you can put the oxygen, you can put the helium thread, and then you have a pressure gauge here, and you have also a meter here. So you can trim the flow from 0 to 2, 4, 5, 6 liters per minute. That is generally used for providing oxygen, you know, from the cylinder. But this is very good also for the gas analysis. This is for sure one of the best way of making the analysis when you do that. And then there is also other accessories like the T that allows you during the cylinder filling. You connect this to the cylinder. You come here with a hose coming from the compressor. This is a special thread made for with any kind of cylinder of the hose coming from the compressor, Bauer, Nadi, Coltree, Alkin, spare air, every can be used this. Then you put here the flow adapter. Okay. Then, okay, you turn on the valve. You start filling from the compressor here, and then during the compressor phase, you can spit out a bit of gas that you may use, with the hose. We may use and go into the analyzer. So this is a good way of making the analysis, the gas analysis during the. You see here. You see, and then in this way, oh sorry, I forgot to turn the unit on, and then do the stuff. Okay. So these are typically the way you do the analysis. But as I told you, the most common system is this one. The rubber cap on top of the cylinder, and then you do the analysis. Okay, now. Let's talk also about some tips. Okay, let me share again the video. Okay, you see now the screen. Hello, gentlemen.
Yes, we do.
Okay, sorry. Okay. Which are the measurement tips when you do the gas analysis? Okay, if you have any doubt, use of course different analyzers, different brands, different sensors, because it is not always good to have only one gas analyzer for the whole diving center. Mainly if you have 100 of cylinders per day, because if something happens, and then I tell you that happens, you need to be ready to do the analysis with another analyzer. Or if you have any doubt, like what happened you remember with the hot cylinder of oxygen, you had to have a different analyzer that maybe was in the office with a stable temperature for C. Of course, the sensors and the analyzers must be protected and must be cared. Don't forget that the analyzer is an electronic instrument. It's like your computer. It's like your telephone. You don't leave your telephone unattended under the sun, or you put on the spray of the sea or the computer. You take care the same as you are using your telephone or using your computer, with the analyzers and with the sensors. Stay away as much as you can from the humidity, high temperature, high humidity, and saline. So meaning that don't put the analyzers in the boat, in a hatch into the boat, and the inflatable boat that you have, the rib you have in the sea. Never store there. Bring always home. Keep carrying your analyzer as it is your dive computer. It is the same cost, more or less, but the gas analyzer is extremely important. Not only if you are alone, but also if you, mainly when you work in your organization, in your diving, or in your shop, or whatever you are. Then remember to always perform a good calibration. If you don't do good calibration, if you don't do reliable, so you must know what are you doing, what could be the issue, what could be the situation. You understand? Then you have to be aware of the calibration that you are doing. Okay, I put also use a known sample gas. That said, that may scare you and say, oh my God, I had to buy a cylinder of sample gas that just for you, between you and me, a cylinder of the one that I showed you cost around from 300 to 400 euro per cylinder, so that is the cost of and then for having that you need at least 2 months, you know, for having, because it's very long, the preparation of the sample gas, because they do the analysis, then they let store, they had to wait for balancing inside, mainly when you use very low concentration. For instance, if you need a calibration gas for 5 ppm of carbon monoxide, that is 0.005%. You remember the concentration, or isobutylene that is 0.5 ppm. It's crazy, you know, that you need time. You know, the gas supplier needs time for providing you. The laboratory needs time for giving you the gas, and but you know, in the diving center we are lucky. Just use a cylinder, the compressed air cylinder. You know, use that. And if you are running at least, as I believe, a good diving center, you have a compressor well maintained. So it means that it has good filters. So it means that you don't have humidity into the cylinder. So it means that you have air, synthetic air. Then use that air. Use the same device that you are using for making the analysis, use for the calibration. Use the pure air. Flow the gas on the sensor for a long time, as I told you the first time you start in the day the analysis, and then go ahead with the gas. The gas coming, the air coming from the cylinder, do the calibration, and then you will have a good sensor and a good analyzer calibrated. Then, of course, if during the day the temperature changes because the temperature is increasing, okay, you need to perform another calibration. But in the meantime, the hours before, you may do a lot of analysis without recalibrate again the sensor, and that is good also if you give the analyzer to the customers. You know, maybe they go to the sea diving, then you give one of your analyzers to the customers, and then they may use for doing the final check of the analysis of the gas before they dive. You know. Flow the gas on the sensor, give the right flow. Don't exceed. Okay, don't never do the error of putting the analyzer close to the valve and then open the valve. That may blast, may destroy the sensor. Always turn on the valve gently and then put the analyzer on the valve. Okay. Then another important, very important, is the practice. You know, it's like everything in life. You know, you need to start. So, and unfortunately, I saw that at the first course that we did 30 years ago, 25 years ago, we spent a lot of time. The instructor was spending a lot of time in training the student on how to use the oxygen analyzer, how to use the gas analyzer, the flow, and blah blah. Now is I saw that is not so deeply taught, this kind of stuff. You know, that's generally is just forgotten, and you say, okay, yeah, you have the analyzer, this is the analyzer, you put on top, you open, and then you have the analysis. That's all, you know. But you know, try to practice, try to teach your student, and try yourself, you know, because when you start using an analyzer, never know what could happen, you know. That is that is extremely important. And then, as I told you before, protect always the analyzer. Take care, don't leave under the sun, don't leave under the moisture, don't leave under the dust. Just try to keep in your office with the aircon, with the dry air. That is the best way of having the analysis done. Okay, understand? Well, so at this point, any question, guys?
Not on my side.
Okay, so I believe that we can. Okay, we can do some exercise. Okay, I should be again now a full screen. You see me?
Yes.
Okay. Well, okay, let me take the NITROX cylinder. Okay, you see that? Okay, so this is a cylinder. That is a simple aluminum cylinder. It contains I don't know. I was given to my compressor, to my blender, and then now I have to know what's going on. Okay, what you do? First of all, you take the analyzer, you turn the analyzer on. Okay, and now this kind of analyzer have an automatic calibration. You know, it makes compensate the temperature, compensate the flow and everything, and then make the automatic calibration, assuming that we are in air, in 20%, 21% of air. Okay, now you see, I see the reading. Okay, so what I do? Okay, let me. Okay. Do you see the reading? Okay. Never, I told you, open gently. Can you hear the flow? Okay. Can you see the reading?
Yes, 48, 49, 50%.
49.8, 40, 42, 43.
No, to 50% oxygen.
Yeah. 50.7. I would say that this is 50.8. Okay. Then I can turn off the valve. Okay. Then, you know, I can tag. Then we do after we do the different situation. Okay, now the sensor, okay, is going down. Probably it won't go to 21% because he has some oxygen inside. You know, so you have seen probably most of the people doing this. You know, shaking the sensor for helping, but it's very difficult. Or they okay. They inhale for removing the oxygen, but you know, generally the sensor doesn't go to 21%. It's lazy, you know. Say, oh my God, why it's not going down? And then what they do? They do a calibration again. They perform another calibration. But this is not a good behavior, guys, because the sensor was already calibrated. Okay, now let's keep the calibration. Okay, now it's went back to 21%. Okay, unfortunately, I gave you a very high quality sensor, very high quality analyzer, but generally, you know, you don't go up to 21. It stays 21.3, 21.5, 21.9. And what you do? Okay, you force the calibration, you know, the manual calibration, and then you go back to 21. Then you spoil totally the analyzers, and then it's very difficult to go back to the real analysis. Okay, now let's see the difference using other device. Okay, let's start using for instance, the flow adapter with a needle valve. Okay, I turn off, I turn on the valve, then I connect the hose to the analyzer. Okay, and then I gently open the. Okay, can you hear the flow?
Yes.
Okay, let's see what will happen. That could be a better way of making the analysis compared for what we did before, just putting the rubber hose, the rubber cap on top of the cylinder. 50.7. You see? Doesn't go 50.8. Oh, okay, now it's going. Okay, so now I have two different readings, the same reading with two different methods of analysis. So I can be quite sure that really in this cylinder there is a 51%, 50.8% of oxygen. Okay, you see that the reading is stable. I say, okay, that's okay. I can go. Okay, now let's go back with another method of analysis. Okay. So we leave the sensor here. We don't need to go down to making another calibration because I'm already done. I just disconnect this and I go down with a new device. Okay. Can you see well, guys, the system?
Yes.
Okay. I turn the valve on. I see there is 120 bar. Okay. Then I connect the hose. This is the medical hose. Of course, this is oxygen compatible and so on. And you see here the sensor didn't go back to 21%. No, doesn't matter. Just connect. Okay, and now open. Flow again. Let's see what will happen. You remember the sensor was in air, was not showing you 21%, was showing around 30%, but the sensor was already calibrated. Okay, so don't mind. If you did a good calibration, you don't need to go back to 21%. Okay, now you see the sensor is giving exactly the same reading. Let's see. It goes to 50.8. Maybe not. Okay, it goes 20.7. That's it. That's it. Okay. Then I remove. I leave the sensor here. Then I use another way. Hello, Arthur. Okay, now I go with a regulator. Okay. Well, this is a standard cylinder, 110 bar, as I was having before with the other analyzer. Then I can use the hole here. Look, the sensor is 29%. It doesn't go down. I don't care. I already did the calibration. Now I remove the flower adapter. I connect the flow adapter to the sensor. Okay. Then I leave the, see the sensor is 21.1, doesn't go down. Don't worry, you know, you did a good calibration. Because now I'm holding the sensor in the hands, then the temperature is increasing, the sensor temperature is increasing, and the reading is higher, just the 1.1%, that is enough, you know. Now, I turn on the valve here, then I can see what will happen with the, where is the hose? Here. Let's see. Oh, guys, when you do this way with the cylinder, with the hose, with the regulator, and with the hose, always be careful that there is no salt water in the hose, because if there is salt water, for sure it will wet the system inside, and then it will stop, because when there is a crystal on the air, maybe you may have the stopping the flow. You see, guys, you have the same reading, 50.7. Okay. So this is something that really tells you, okay, this is at 50.8 or 50.7 percent oxygen cylinder. Okay, what you do now? Easy. I told you. You take the tape, or if you have a better, sticker of your diving center, you write the date. Today is the 26th. October 22. See, this is a 50.8%. Okay. Then who calculates for me the MOD at 1.4 or 1.6?
21. 21, no. I didn't calculate it, but that's what we use.
Okay. How much would be? It would be around 19 meters.
At 1.6.
Yeah. Okay. Let me take the. Is 0.58 divided 1.6. Yeah.
But you don't use the decimal, no?
Yeah, it's around 19 meters. Okay, so I do the sticker. I remove, and I stick on the cylinder. Okay. So now I can deliver the cylinder to my customer, and the customer have to check if the concentration is close what they say. Okay. Never forget doing this. Okay. That's extremely important. Then, of course, make a print of your diving center with your sticker, whatever. But always have this kind of behavior when you do. Okay, now I left the sensor. You see, 21.8. I can remove the adapter if I want, and then let's see what will happen. Oh, it's going down. Oh, went back to 21. Oh, now it's 20.9. You see? Okay, in case you want to do again the calibration, you keep here. This is not necessary, but I just want to show you what happens. Okay. Now I'm again 21%. Then I can show you another trick that was happening in some countries, not in Malta, but in Egypt, yes. I have many episodes of that. I'll show you what happens. Okay, I connect again the sensor. Okay, then, can you see, I start the analysis. which is the reading. Okay, now it's for 25, 26. Oh, I forgot to show you that the sensor holes have here some holes. You see? And you see the holes for the air going out. Let's see what will happen if I keep close the holes, meaning that I increase the pressure on the sensor. Look. You see the reading? Wow, 25, 53, 55. You see? You see, guys? This is not magic. Just because I'm increasing the pressure on the sensor. So, and it was happening at the beginning of the NITROX era. That was the guys for saving oxygen was just covering the holes, you know, the holes of the sensor, just for increasing the pressure, and then the reading of oxygen was increasing. You know, that was a scam. You know, for they were mixing NITROX only 28, 27% saving oxygen. Then when were going to analyze, they turned on the valve, they close the hole, the pressure increasing, and then they say, hey, look, the concentration is around 35%, 36. Okay, let's use that, but then let's use the A table, you know, for safety. Okay, that happened. So Artu, was you that was doing the analysis?
Yes, I was analyzing like that to save the oxygen.
Okay. And what happened with pure oxygen?
What do you mean? The analysis of what?
I use the NITROX 50%. Okay, now we can do an experiment with pure oxygen. Just give me a second. Let me take a pure oxygen cylinder. I'm here, guys. Okay, this is a medical oxygen. Okay, so let me remove. This is medical oxygen. Okay. Oh, let's do the different way. Can you see, guys, the display?
Yes.
How much is showing?
98, 99, no? 100?
100, okay. That's good. So as you can see, the sensor was well calibrated, and then now the sensor is giving also the good accuracy with also with pure oxygen, even if we are very far from 21% that we did the calibration. But that is because the sensor is good, and I really believe that the quality of these sensors, they are special.
But if you under calibrated, like say it's 21% and you calibrate it to 20, when you put it on 99 or 98% oxygen, will that not show 100% as well?
Correct, absolutely. We show 90%, something low. You wanna do the try?
Another trick.
Okay,
I know about them because I was teaching the Egyptians how to do the other one.
Okay. I don't tell this to Dr. Maroni.
No.
Okay, let me change the calibration point of the unit. Okay, now I'm changing the calibration point. With this unit, I can do that. Okay, let's point at 19%, for instance, okay? Okay. Well, now, okay, guys, what we are doing is we are messing up everything, you know, we are doing a wrong calibration. We are assuming that we are now at 19% of oxygen. That is not true, okay? Now, I give. Let's see what will happen.
It will give you an error, right?
Yeah, of course, 5%.
Because it's more than 100.
Correct. You see, it doesn't go to 100%. And this is not because the oxygen is not pure, because we did the wrong calibration. You see?
You can do it the other way as well to make
of course.
the low percentage go.
Now I can do better. I can go to the calibration. I can set 99%. That is pure oxygen, okay? Then I'm flowing pure oxygen and I can say, hey, analyzer, I'm in 100% oxygen. I'm doing the calibration now. Okay, now I can turn the valve off. And then I can see what will happen in air when it goes below 90%. Let's go back to the NITROX cylinder and let's see what will happen. Okay. Let me add the rubber cap. Okay, can you see the screen?
Yes.
Sorry. Oh, yeah. How much is?
49.7 at the moment.
Okay.
$49.
Yeah, if I'm going out. You see?
Mm-hmm.
You are 49.6.7. So you have a 1% error because you did the calibration with pure oxygen, 100%. Okay. And now going down, you have an additional error of 1%. So understand, guys, how is important the calibration with the with the closer gas. The closer you do the gas, of course, when you do the calibration with this kind of gas, you need to be not to have rush. You know, you must be. You have your time. You keep waiting, and then you can wait. Now I'm curious to see what will happen to the analyzers if it goes back to 21%. I can remove the adapter. And then also, guys, don't underestimate when you use pure oxygen in a closed area like mine, like my office here, even if it's quite big, you know, you have increase of oxygen into the room, so you don't use the ambient as a 21%. You know, maybe you have 21.5, 21.6 easily, very easily, even if you use pure a very, very low bar of oxygen, pure oxygen. The ambient oxygen will change, so don't use that air for doing the calibration.
Be careful, Eugenio, eh?
Yeah.
Too much oxygen.
So I will be very happy now. Yeah.
No, but you need to be careful of hydrocarbons as well.
Yeah, correct.
Niente sigaretta, eh?
Correct, don't use. And you see, now it went to 20.6, didn't go back to 21 because I calibrated on 99.9, and then now we are around 1% of error, below 1% of error. Understand? Now I should take the calibration. Okay, now what I can do is I can go back to the original calibration of air. I reset the unit, and then it will make a calibration of 21%. Okay, calibration. Otherwise, I had to turn, you know, the screw, the trim, and now I'm 21%. Okay. Now, if I go to the cylinder again, let me see what could happen. Oh, I had to turn the. Can you see? Wow, 20.8. I got the same value. Okay, so I believe that we can say that the cylinder was really 50.8% of oxygen. Okay, so gentlemen, we arrived at the end of our lecture. I'm very sorry that you are only the three of you. I'm so sorry, but I hope that okay, we are recording, so we can you can use also, you can tell your colleague to, you know, to watch the recording, and so they can see. I hope that it was useful for you, even if I know that you are already aware of this, Cadius and Damien and Arthur, about this calibration and this
not
gas
to this detail, Eugenio, not to this detail.
Okay, thank you.
So we calibrate gases, but yes, we do a lot of mistakes from what I just learned.
So this is why we are here. I
Yes,
wanted to try to tell you the tips, you know, what's behind, so you can understand now.
Yes,
and
yes.
then now
I am a breather now.
Yeah, correct. It would be easier for you to perform a better calibration. Okay, so just for making a quick review of what we did today, we have seen the calibration, the importance of the calibration. We have seen the sensor of the gas analyzers, how they works. We have seen that it's important to calibrate and to take care of the flow, of the temperature, of the pressure, because the pressure affects a lot, and also the temperature affect the reaction. Remember that the sensor is differential, is not absolute, so it means that it makes a difference between two values, and then you have to state one value, that is the calibration value. Then we did some tests with a real life cylinder, and then you have seen what happens, you know, if you mess up the pressure, if you mess up the temperature, if you mess up the concentration. So guys, as always, it's a real big pleasure for me to share my knowledge, my small knowledge with you, and then I really hope you enjoyed this lecture. And please, let's keep in contact. Guys, I don't know if you have any question. Please send me an email. I will. Let me give you my email address, because I don't use very often the ITS. Okay, this is my personal. Can you see in the chat my personal email?
Yes,
okay.
thank you.
Please, if you have any question, if you have anything, you know, you just send me an email, and then I would be very happy. Or you send me an email, and then I will call you if you in case you need to talk to me. So no problem. I can give you my Skype, my team, my WhatsApp contact for having a chat. Okay.
Thank you very much.
Thank you.
Thank you, guys. Thank you.
Thank you.
Now I'm stopping the recording. Bye.
Bye.